Hey guys, today we're going to learn about the quotient rule. Now the quotient rule obviously we use when we have two functions that are being divided. So for example, here we have h of x is equal to 2x minus 1 over x plus 3. This particular function cannot be rewritten in polynomial form, so we would have no choice but to use the quotient rule. Now the quotient rule is as follows. If you have some function where h of x is equal to f of x divided by g of x, meaning one function divided by another, then h prime of x, the derivative, is equal to g of x times f prime minus f times g prime all over g of x squared. Now, I remember it in this way. I use this trick, which my calculus teacher taught me in high school, which was low d high less high d low, O low squared. So it's kind of like a little song. Low representing the denominator, high representing the numerator. So low, the denominator, times the derivative of the numerator, less minus. High, the numerator, times d low, the derivative of the denominator, over the denominator squared. So let's try this out. We have h of x is equal to 2x minus 1 over x plus 3. If I want to find this derivative, I would have to apply the quotient rule. So I put here in blue, f of x is 2x minus 1, that's the numerator, and g of x is equal to x plus 3, the denominator. And we want to find the slope of the tangent line when x is equal to negative 2. So first we need to find the general equation for the derivative. So h prime of x is low, so x plus 3, d high, the derivative of the numerator, so 2, less high, so 2x minus 1, d low, the derivative of the denominator, which is just 1, all over low squared, so the denominator squared. Now we're just going to distribute and combine like terms in the numerator, but for the denominator, you can just leave it as x plus 3 squared. You do not need to actually distribute that. So h prime of x is equal to 2x plus 6 minus 2x plus 1. And everything once more is over x plus 3 squared. The two x's cancel out, and so our final derivative is equal to 7 over x plus 3 squared. Now, since I want to find what is the slope of the tangent line when x is equal to negative 2, I'm going to plug in negative 2 into my derivative. So that would be 7 over negative 2 plus 3 squared. So that's 7 over negative 2 plus 3 is 1, and 1 squared is 1. So the derivative when x is equal to negative 2 is 7. Let's try that again. We have here tangent of x, and we want to find the derivative of the tangent function. We have already seen that the derivative of sine and cosine is, the derivative of sine is cosine, and the derivative of cosine is negative sine. So we are going to need to know the derivative of all of the other trig functions. And to find the derivative of every other trig function, what we use is the quotient rule. So we have to keep in mind that tangent of x is sine of x over cosine of x if I want to find this derivative, which is, as you can see, a quotient. So I'm going to say that f of x is equal to tangent x. So I'm trying to find f prime of x, remembering that tangent of x is sine over cosine. So here we go. Low, cosine x, times the derivative of the numerator, which is cosine x, less high, so sine x, times the derivative of the denominator, which is negative sine x, all over cosine squared x. Now if I distribute, multiply and combine like terms, we get cosine squared x plus sine squared x, all over cosine squared x. Now cosine squared plus sine squared should look familiar. This is a Pythagorean identity. And this Pythagorean identity, just so that you can keep that in mind, is cosine squared x plus sine squared x is equal to 1. So I can basically replace all of this with 1, which is equal to 1 over cosine squared x. Now also, we know that 1 over cosine is secant x, because that is the reciprocal function. So the derivative, if I don't want to write it as a fraction, is equal to 1 over cosine squared, which is secant squared x. So this is the derivative of tangent. Now, if I look at all my other trig functions, we've already done the first three. The derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent, which we just figured out, is secant squared. Now, for the rest, you can also apply the quotient rule, keeping in mind that secant is 1 over cosine, cosecant is 1 over sine, and cotangent is cotangent over sine. But eventually, you do just have to memorize it. The derivative of secant is secant x tangent x, and the derivative of cosecant is negative cosecant x cotangent x, and the derivative of cotangent is negative cosecant squared. So you'll notice that there are some patterns to these derivatives. So for the derivatives of secant and cosecant, the derivative is secant again, and then multiply with tangent, and then the derivative of cosecant is negative cosecant and cotangent. So it's kind of like the cofunction of secant, which is cosecant, and the tangent is cotangent, so they're related. Regardless, if you can't remember it, you can always apply the quotient rule to help you find those derivatives. Now let's showing that this works, we're going to use the quotient rule to find the derivative of secant x, meaning that you are going to use this. So secant x is 1 over cosine x. So if I wanted to find the derivative of secant, I'm going to use the quotient rule for 1 over cosine x. So low cosine x, d high, the derivative of 1 is 0, less high 1 times the derivative of the denominator, which is negative sine x, all over cosine x. Now when we work this out, this is just 0. Negative 1 times negative sine is a positive sine x over cosecant squared. Now from here, how does this equal to secant x tangent x? Well, we see that in the denominator we have that cosine squared. So we can actually split this fraction. This is sine x over cosine x times 1 over cosine x. See, if I were to multiply this back out, I would get sine over cosine squared, which is what I have. So I can split my fraction if it's over a monomial and everything is multiplied. Now sine over cosine, this is tangent x. And 1 over cosine is secant x, which is the equivalent to secant x tangent x. Let's try a few more problems here. We're going to use the quotient rule for these two, obviously, because there's no other choice. For f of x, we have x squared minus 2x over x plus 2. So here we go. Low, x plus 2, d high, 2x minus 2, less high, x squared minus 2x, times d low, which is just 1. And everything is over x plus 2 squared. So now we're going to have to distribute the numerator and combine like terms. So let's go ahead and distribute over here, which would give us 2x squared minus 2x plus 4x minus 4. Now I'm going to distribute this negative, so minus x squared plus 2x. all over x plus 2 squared. Now here I have this negative 2x and this positive 2x, so that will cancel out. So our final answer, f prime of x, is going to equal to x squared plus 4x minus 4 all over x plus 2 squared. Let's try that with g of x. So g prime of x is going to equal to x plus 2. We already saw the derivative of tangent is secant squared. Minus, so low d high less high, so tangent x d low, which is just 1, over x plus 2 squared. When we look at this problem, if you were to distribute this x plus 2 with this secant squared, it's not going to help our derivative out, meaning that it's not going to look any nicer. So you don't have to actually distribute it. You can just leave this as x plus 2 times secant squared x minus tangent x all over x plus 2 squared. You can't really combine anything else. You can't simplify anything at all. So this would be our derivative. Let's look at a more complex example. Show that using the quotient rule that if f of x is equal to x squared plus 3x plus 2 over x squared minus 1, then f prime of x is equal to negative 3 over x minus 1 squared. Now when we first look at f of x, obviously this is a quotient, so we will have to use the quotient rule. But if I notice that in the numerator and in the denominator, I have quadratic functions. So what I can do is try to factor them and see if I can simplify that rational function first. And that's because if I can simplify before I use the quotient rule, then as we use the quotient rule, we're less likely to make a mistake because we don't have such a complicated function. So let's see if we can rewrite first f of x a little bit simpler. So f of x here in the numerator, x squared plus 3x plus 2, can be factored to be x plus 2, x plus 1. And x squared minus 1 in the denominator is a difference of squares, which is x plus 1 times x minus 1. So I can see that these x plus 1's cancel out, and I'm left with f of x as x plus 2 over x minus 1. This is much easier now for me to apply the quotient rule. So here we go. F prime of x is going to equal to low x minus 1 d high, which is 1, less high x plus 2 d low, which is 1, all over x minus 1 squared. Now if I distribute and combine like terms, I get x minus 1 minus x minus 2 all over x minus 1 squared, which when I work this out, these x's here cancel, and I'm left with negative 3 over x minus 1 squared, which is the equivalent to what we were trying to find. Now let's go ahead and look at some graphs. Below are the graphs of f of x and g of x. Let p of x equal to f of x over g of x and r of x equal to sine x over f of x. And we're going to use these graphs to answer the following questions. So we see here for this first box, we're going to find the equation of the tangent line to p of x when x is equal to 6. Remember that we always need first to find the point of tangency and then the slope of tangency. Doesn't matter which order you choose, but you do need those two things. So we're going to start off with p of 6 to get my point of tangency. Now p of x is f of x over g of x. So p of 6 is f of 6 over g of 6. Now when I look at my graph here, f of 6 is negative 4 and g of 6 is 6, leaving me with my point of 6 and negative 2 over 3. So that's my point of tangency. Now we're going to find the equation for the derivative of p of x. So that way I could find my slope. So p of x is just f over g, so the derivative would be g of x times f prime of x minus low d high less high, so f of x, d low, which is g prime of x, and everything is over g of x squared. Now I'm ready to plug in the 6. So p prime of 6 is going to equal to g of 6 times f prime of 6 minus f of 6 times g prime of 6, and everything is going to be over g of 6 squared. Now I'm going to use my graphs here to find these values. G of 6, as we saw earlier, is 6. F prime of 6. Now when you look at your graph, this is f of x, and to find f prime, you find the slope of the line. So when I look here, I need to go down 1 or right 2. So the slope of f of x when x is equal to 6 is negative 1/2. Minus f of 6, which is a negative 4, so we'll make this a plus 4. And then g prime of 6, again, this is another line, so we need the slope of the line, and the slope of this line is 1. And everything is going to be over g of 6 squared. So g of 6, which is 6, and 6 squared is 36. Okay, so now let's just get this value. 6 times negative 1/2 is negative 3, and negative 3 plus 4 is 1. So we get our slope of 1 over 36. Now I'm ready to write the equation of my tangent line. Remember that this is my point of tangency, and this is my slope. So here's my line. Y plus 2 over 3 is equal to 1 over 36 times x minus 6. Moving on to this next question, find the equation of the tangent line to r of x when x is equal to 0. So here we go. First, like we did before, we need the point of tangency. So I need r of 0. So I come here and I look at my function, which is sine of 0 over f of 0. Now sine of 0 is 0. And f of 0, if I look here, is negative 5. Now I do this anyway just to make sure that my point is not undefined. In case we have a 0 in the denominator, then there is no tangent line. But either way, 0 divided by anything is 0. So my point of tangency is 0, 0. Now let's find the derivative for r of x. So I'm looking for r prime. And again, I'm using my function here. So low, f of x, d high, which is cosine x, less high, which is sine x, times d low, which is f prime of x, all over f of x squared. Now I'm ready to plug in 0 so I can get my slope at x is equal to 0. So that's going to be f of 0 times cosine 0 minus sine 0 times f prime 0 all over f of 0 squared. Now, here we go. F of 0, when I come here, is negative 5 times cosine of 0, which is 1, minus sine of 0, which is 0, and 0 times anything, whatever f prime of 0 would have been, would just be 0. So it would be minus 0. And everything is over f of 0 squared. And f of 0 is negative 5. So negative 5 squared is a positive 25. So when I work this out, I get negative 5 over 25, which can be simplified to -1 over 5. So now I have all my information. I have my point of tangency once more, which is 0, 0, and my slope of tangency, which is -1 over 5. So my equation is y minus 0 is equal to -1 over 5 times x minus 0. Now you can leave your answer like this, or because of all of these zeros, you can also say that the equation is y is equal to -1 over 5x, which is also an acceptable answer. Now we're going to go ahead and look at some charts. So here we have a chart of f of x, g of x, f prime of x, and g prime of x. And the first part here says to estimate the value of g prime of 2.5. Now, although this has nothing to do with the quotient rule, it's always good to review previous material. So if I wanted to estimate the value of g prime of 2.5, remember when we are estimating, we need to use a point to the left and a point to the right of 2.5. So that means I'm going to use x is equal to 2 and x is equal to 3. So this is going to be g of 3 minus g of 2 over 3 minus 2. Remember, when we're estimating a derivative, what we're doing is we're finding the slope. And this is slope formula, y2 minus y1 over x2 minus x1. Now we're going to use our chart here to get these values. G of 3 is -3 minus g of 2, which is -1, so plus 1 over 3 minus 2, which is 1. So now when I work this out, -3 plus 1 is -2, and -2 over 1 is just -2. So this is approximately g prime of 2.5. Moving on to this next one, we have if p of x is equal to g of x over f of x, what is the value of p prime of 4? What does this say about the graph of p of x when x is equal to 4? And give a reason for your answer. So first let's find what p prime of 4 is, and then we can answer that follow-up question. So first I need the general derivative for p of x. So p prime of x is low, so f of x, d high, so g prime of x, less high, g of x, times f prime of x, all over f of x squared. Now I'm going to go ahead and plug in 4. So p prime of 4 is going to equal to f of 4 times g prime of 4 minus g of 4 times f prime of 4 all over f of 4 squared. Let's use our chart to get these values. F of 4 is 1. G prime of 4 is -2 minus g of 4, which is 7, times f prime of 4, which is 8. And everything is over f of 4 squared, which is just 1. So now again, let's get this actual numerical value. We have in the numerator -2 minus 56, and -2 minus 56 is -58, which is over 1, so -58 is my slope. Now what does this say about the graph of p of x? Now what this says, right, when you have your derivative, remember that the derivative tells you when your graph is increasing, decreasing, or when it has a horizontal tangent or some kind of extrema. So since my derivative is negative, this means that p of x is decreasing at x is equal to 4 because p prime of 4 is less than 0. Now let's move on to the next part. We have if q of x is equal to 2x squared times f of x over g of x, what is the value of q prime of 2? Now if you notice your q of x function, this is not only do you have a quotient in there, but you also have a product. So when we work this out, this is a combination of product and quotient rule. Now you can kind of tell that since the main rule we're going to have to use is going to be the product, because the product is going to come before the quotient, since the quotient is inside of that parentheses. So when we find our derivative, we have q prime of x. And the product, you'll remember, is the derivative of the first, so 4x. Leave the second alone, so f of x over g of x. Plus, leave the first alone, so 2x squared, times the derivative of the second function, which that is my quotient. So this is where I'm going to have to use the quotient rule. So that's going to be g of x times f prime of x minus f of x times g prime of x all over g of x squared. And now we're going to have to plug in 2. So q prime of 2 is going to equal to 4 times 2, which is 8, times f of 2 over g of 2, plus 2 squared is 4, and 4 times 2 is 8 again, times g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 squared. And I apologize that it's all slanted. Okay, so now let's plug in these values so we can get our actual numerical answer. So we have this 8, f of 2 is 2, over g of 2, which is negative 1. So 2 divided by negative 1 is negative 2, plus 8 times, now g of 2, negative 1, times f prime of 2, which is 9, so negative 9, minus f of 2, which is 2, times g prime of 2, which is negative 1, 2 times negative 1, oh, no, it's not, 2, oh, yes, it is, g prime of 2 is also negative 1. So 2 times negative 1 is negative 2, so negative 9 plus 2, all over g of 2 squared, which is negative 1 squared, so just 1. So what this gives me here is negative 16, and then 8 times negative 7, because negative 9 plus 2 is negative 7, is negative 56. And negative 16 minus 56 is negative 72. Last question here. Find the equation of the line tangent to the graph of v of x if v of x is equal to 3x over g of x when x is equal to 3. So I'm just going to erase this little bit here so I have a little bit more space to write. Okay. So first I need that point of tangency, so I need v of 3, which is going to equal to 3 times 3, so 9, over g of 3, which is negative 3. 9 over negative 3 is negative 3. So that's my point of tangency. Now we need our slope, so I need to find the general equation for the derivative. V prime of x is going to be low, so g of x, d high, which is 3, less high d low, which is g prime of x, and everything is over g of x squared. Now I'm going to go ahead and plug in the 3. So v prime of 3 is going to equal to g of 3 times 3 minus 3 times 3, so 9, times g prime of 3, and everything is over g of 3 squared. Let's plug in these values. G of 3 is negative 3, and negative 3 times 3 is negative 9, minus 9 times g prime of 3, which is 6. And all of this is over g of 3 squared. And g of 3 is negative 3, so negative 3 squared is 9. So what this gives me here is negative 9 minus 54, which is negative 63 over 9, which equals to negative 7. So that is my slope. So now we're ready to write the equation of the tangent line. We have our slope of tangency, which is 3 and negative 3, and we have our slope, which is negative 7. So my equation is y plus 3 is equal to negative 7 times x minus 3. And that's it. That's the quotient rule.